Hello everyone, my name is Owen Lowe and I am a research student at Edinburgh Napier University. As part of my research, I have been working alongside the team involved in the data capture and auto-identification reference project, DAKAR for short. In this brief video, I will be demonstrating one component of the DAKAR project, which is the patient simulator. Before I begin, I will provide a short summary of the DAKAR project. In essence, the DAKAR project provides for an integrated cloud infrastructure for the healthcare industry, one in which security, auditing and policies are all part of the implementation. To achieve strong security, the use of the Kerberos authentication system is implemented in conjunction with a single point of contact system to grant access privileges. When a user wishes to access any service within our cloud, the user must first be authenticated with the Kerberos system. It will then be granted a token which it passes to the SPOC, and the SPOC will allow for access to the service depending on the user's privilege. So what type of services will this cloud infrastructure provide? Well, in terms of healthcare, one of the main purposes for this cloud infrastructure is the storage of patient records. Traditionally, patient records have been paper-based. Unfortunately, paper-based records contain too many errors and inefficiencies. Therefore, we have moved towards electronic health records. Currently, most implementations of electronic health records are considered static. However, static records have their own problems. For example, they are often localized, different systems or different formats, they have poor access control, and there's very little ability to verify the identity of the patient. Furthermore, they cannot be aggregated. In the DAKAR project, our cloud infrastructure allows for the capture of dynamic patient records. In other words, we don't only capture static patient attributes such as the patient's name, the patient's date of birth, the patient's address, but also dynamic attributes such as clinical measurements, heart rate, blood pressure, temperature, along with the location of the patient, any events which have taken place, the time of capture, the capture role, in other words, who actually captured this data, such as a nurse or a doctor, along with the device ID. For example, what type of a device actually captured the patient's data. All the data which is captured will be stored on the cloud in what is known as data buckets. In order to test and evaluate how effective these data buckets are, we need to find some way to feed the data buckets with, well, data. This is where the idea of the patient simulator comes in. As the name implies, the patient simulator allows us to simulate a patient's attributes. In particular, we attempt to simulate the physiological signs of a patient, including heart rate, blood pressure, respiratory rate, temperature and SpO2. A prototype of the patient simulator, which is able to generate these 5 physiological attributes, has been developed within the last few weeks, and after a short pause I will provide a demonstration of this simulator. Okay, so I've loaded up Microsoft Visual Studio, and in front of us is the patient simulator. It was developed in .NET C#, but for the purpose of this video I won't get into too much technical details on how it was implemented. The purpose of this video is to simply give you a short demonstration of this prototype. Within this window here, we can define the attributes of heart rate, temperature, respiratory rate, blood pressure and SpO2. We define a mean along with a standard deviation, and I'm just going to stick to the default values for the time being. Over here we can define how long we wish to simulate a patient's attributes. I'm going to enter 240 seconds and we'll run it at a speed of ×1. So now we can see that each of the 5 physiological signs start generating data. Over here we have a graph view where we can actually view each of the physiological signs in form of graphs, which are generated in real time. So we have here the heart rate, the temperature, blood pressure, and respiratory rate, and SpO2. The patient simulator allows us to also speed up the time of simulation in order to quickly feed data buckets in order to test how well it copes under stress and load. So if we speed this up now, you can see that the graphs start moving a lot quicker because we're working at 5 times the speed of normal. Now, another interesting part of this patient simulator is that it allows us to simulate not only normal status of a patient, but also currently a dead patient and gastrointestinal bleeding. If we change the status of the patient to dead, we should now see that all the data which we generate will result in 0, and the graphs. As you can see, the heart rate plummets to 0, temperature plummets to 0, well, the same for each and every physiological sign. If we now stick it back to normal, the patient is revived and starts generating some normal attributes. In the case of gastrointestinal bleeding, which is the case where a person has internal bleeding, the person starts losing blood, therefore his blood pressure will go down, whilst his heart rate will increase to compensate for his loss of blood. And let's see what happens when we place the patient status into this. As you can see, the heart rate starts going up, and we should see that the blood pressure has dropped, which is the case here. And if we just speed up the simulation a little bit, it becomes a bit clearer. And that's our 240 seconds up, and the simulation has completed. I hope you found this video quite interesting, and thank you for your time.